Good morning, guys. And this is the first session about the introduction to embedded system. And in this session, I'm myself Suri Prakash from Kumbhaluru College of Technology, and I'm going to be teaching you the embedded system for an information technology students. And in this session, we're going to see about the basics of this system and the definition of embedded system. And also we are going to see about what are the applications such as examples of embedded system, and also we are going to see on what are the components involved in embedded system. And also in addition to that, we are going to see about the various consideration that has been dealt by system engineers. And next we are going to see on the categories of embedded system, such as various classification of embedded system based on its performance and functional criteria. Consider this is a system. In the screen, you're going to see about the dial and the internal parts of the dial of a watch. And this is a system which has a various components such as the dial of a system, and then there is a three needles are there. And these three needles which shows the time of a particular instant. For example, this is working in a proper way. For example, if you consider the seconds needle, and this needle rotates around the dial, and then when it's reached the same position, the next needle, that is the minutes needle, will move to the next position. And then when it rotates to the particular inside the dial, and the third needle, that is the hour needle, will move from 4 to 5. And this is how the system works. So, yeah, for example, a system is a way of working or organizing or doing one or many tasks according to the fixed plan. So that is a fixed plan, a program or set of rules. In a software, you can define the rules. So such as examples of a system is a time display system, for example, a watch, and also a cloth washing machine. We can tell it as a cloth washing system, a washing machine. So there are varieties of washing machine which has a mechanical, only mechanical and electrical part involved. For example, when you going to include any coding, so this is called as an embedded system. So we're going to see about the definition of an embedded system. Embedded system is a system that has a software embedded into the computer hardware, which makes a system dedicated for an application or a specific part of an application or a part of a larger system. So a embedded system which has both hardware and the software part, which is included in a single system, which is dedicated for a single purpose. So this is about the definition of embedded system. So next slide, we're going to see about the examples of the system. On the right side, you have seen the varieties of application and the picturized view. The left side, these are the varieties of application such as television, automobiles, MP3 players, cell phones, GPS, microwave, home alarms, thermostats, network router, game consoles, ATM machine, and aircraft and satellite systems. For example, if you consider a network router, and this has its own software and its hardware, so which its main purpose is to routing and gives the shortest path in networking. For example, if we consider the GPS system, so this gives a prior location of a locate by using the XYZ axis of a particular system. So this indicates where the particular person is available. And also, if you consider the ATM machine, it's looked like it's having a general purpose system as a computer, but it is dedicated for a single purpose, which has been remodeled to do a give the customers money of a bank. So now, so this is all about the small set of examples of embedded system, and we are having the variety of application. So this is embedded system is still growing. The next slide, we are going to see about the components of embedded system. Wait. So before going to see about the components of embedded system, we must know what are the components of a computer system. So when we're discussing about the components of computer system, the first thing comes in our mind is the microprocessor. So what kind of microprocessor are we going to use? The major player for a microprocessor in India is the AMD and the Intel. Sorry. So Intel has a varieties of classification in microprocessors, such starting from the Intel Core Duo, from my knowledge, Intel Core Duo and Intel Pentium boards, and then i3, i4, i i3, i5, and i7, and then we are now still working on it, i9. So next thing is the memory. So how much amount of memory we're going to use for the computer system. So we are basically classifying the memory as a primary memory and secondary memory, and we will see the elaborate view of memory in the next session. The next thing is the I/O unit. So basically for a computer, the input devices is primarily a keyboard. It's an ASCII based keyboard, and then the output unit is the display. In order to process with the GUI functionality, we will be using the mouse, and then the networking unit. The networking unit primarily will be having the USB port, and then we'll be to connect with the internet, we'll be using the Ethernet and Wi-Fi. So last thing is the software part, the operating system, to which operating system the system is going to work. And these are the considered as a major part of the computer system. So similar to that, the components of the embedded system will have, this is the block diagram of the components of embedded system for a general system. So this is not a specific for a system, and these are the components will be available for any of the embedded system. For example, if we consider this has a power supply and reset and oscillator circuit. So this is the power supply unit. So in this power supply unit, since it is an embedded system, mostly the power supply of an embedded system will have the 5 voltage or 12 voltage supply. So this is mostly supplied by the battery or the host system to which this embedded system is being connected. And also for a dedicated embedded system which is going to operate in the remote area, which will have the power cultivation from its own solar panel. So next one is the reset circuit. So there is a mistake in the spelling of the reset circuitry. The reset circuitry is primarily important for any kind of embedded system. For example, if there is any software and hardware glitches, no one is going to monitor it. So only thing, the system is going to get resetted automatically, or someone people is going to give the reset button, click the reset button, so the system will again reconfigure to the initial stage. And the third one is oscillator circuit. The oscillator circuit is there seems to be a heart of any system, so which will give the oscillator pulse to the system. The for input and output devices and interfacing a driver circuit. For example, if the embedded system is connected to the motor, and this will give the motor driving pulses, and the processor will give the processing ability to which it's being operated. The timer gives the timing functionality. So we can give the timer functionality through software also, but the timer gives the hardware. It has a dedicated hardware circuit so that it will give the prior timing function. For example, embedded system is operating in the real-time environment, so we need a real-time consideration for designing the timer operation. Interrupt controller. The interrupt controller. So for example, the so any system will have the keys as an interrupt functionality. So we can give the interrupt through external mode and also through internal mode. That is, external mode is by using hardware interrupts, and internal mode through using the software interrupts. And also to connect with the external world, we are having the serial communication ports such as the USB and also SPI, I2C, the serial communication ports where varieties are available. Through SCA and UART communication is being also considered as a serial port, and parallel ports, that parallel ports such as the varieties of parallel port to connect with the LCD or any of the variable device, we will be using the parallel ports. The output interfacing driving circuit and input interfacing driving circuit, and the most important part is the program memory and the data memory. The program memory is where we are going to load the program, and the system going to generate the data, so those data will be stored in the data memory. And then the system application specific circuit. For example, if we are going to use any graphics unit, so we will be using the GPU as a system application specific unit. In the next slide, we are going to see the basic block diagram of an embedded system. So this is consists of the embedded computer hardware and the software, and this is the user interface where the user inputs are values to be given, and this is the input variables, and this is a link to the other system through communication ports, and we'll be getting some output variables in the real-time environment. So this is all about the components of an embedded system. So next we are going to see on characteristics of embedded system. So there are four basic characters of an embedded system such as real-time and multi-rate operation, complex algorithm and complex graphics user interface and other user interface, and then dedicated functions. For example, if we consider the real-time multi-rate operation, if you consider an example of a DTH setup box, so in that you will be getting a the analog, that is a audio and video input to the system through single wire. The system has to decode as an audio to the separate channel and the video to the separate channel. And these two channels are operating as a different data rates. For example, audio will be getting in some data rates and video will be getting in different data rates. And you have to mutually produce the output so that the audio should not overlap video. Similarly, vice versa, the video should not overlap an audio. So both has to be a real time, has to give the real time output, so that if the system fails in processing any of the audio signals or any of the video signal, there will be the huge glitch will be there in producing the output. In processing such kind of the complex algorithms, embedded system do perfectly. It's a clean glitch. It's a clean shot. In a digital, for example, if you consider a DSLR camera, so the huge algorithms, that is the image processing algorithms, are being embedded into the digital camera. So this is processed very easily with the adequate hardware by the DSLR camera. The complex graphics user interface and other user interfaces. The user interface has to be in real time. If you press the button, it has to show the result immediately. If there is any delay, it's not considered. Without real time operation, this system is not perfect. We cannot say it is a perfect embedded system, which has to be at last the final thing. It has to have the dedicated functionalities. For example, DSLR has to give the produce only for the camera operation, and then the printer has to be used for only for the printing operation. So this is all about the characteristic of embedded system. Next we'll see different constraints of the embedded system. While producing the different characteristics, we have a certain consideration: the available system memory, and then available speed of the system, and then power consideration. So we cannot go for the high voltage. We cannot give the enormous amount of power through the direct supply. So most of the embedded systems are operated in the battery operated one. So we can have the limited power supply and the performance also limited. We cannot extract, since the hardware is very much limited, we cannot extract the maximum performance out of the system. Already the maximum limited performance is available inside the system. We cannot go beyond that line. So these are the constraints for an embedded system. The basic components of an embedded processor. So processor, for example, in a system, we'll be having the embedded processor. The embedded processor, the major two systems such as the program flow and data control units, which includes a fetch unit for a fetching instruction from the memory, which will fetch the instruction from the whatever the persons have typed inside the memory. And then there is an execution path. So this will decode the instruction, which includes a circuit of arithmetic and logical unit, and for instruction for a program control task, say the data transfer instruction, halt, interrupts, or jump to the another set of instruction, or call to the another routine, or sleep or reset. This execution unit will make the instruction to decode and execute inside the system. So there are two basic components in the embedded system, such as the program flow and data flow control unit, and then execution unit. So next we'll see the system designer consideration. So the designer has to consider the processor instruction in the instruction set and the processor ability to solve the complex instruction used in the meeting the deadlines for their processing. So we cannot use the Arduino for this heavier graphics operation to solve the graphical operation. We cannot apply the algorithms such as complex algorithm inside the small scale 8-bit control systems. So the maximum next one is the maximum bit in an operand is 8 or 16 or 32 in a single arithmetic or logical instruction. If for we have to consider over the a consideration over the whether we are operating in the 8-bit operation or a 16-bit operation or a 32-bit operation. And then the last one is the internal external bus width in a data path. The data path, we must know before programming the controller, we must know the internal data width, bus width, so that we can program appropriately to do some complex task. So these are the system consideration for designing an embedded system. So we are measuring the performance of embedded system through these three categories: million instruction per second, the capability of a processor to instruct we'll be terming it as it has a 1 MIPS or 2 MIPS. At a second, it will can able to execute 1 million instruction per second. And also, for example, if we consider the DSP based processor, the million floating point instruction per second, that is MFLOPS, and generally will termed as a dry stone and wet stone, alternate metrics for measuring the performance, processor performance. What makes the embedded system so different? So these are the various characteristics: the real-time operation, the size, cost, time, reliability, safety, and energy. So these are the various categories, characteristics which makes the embedded system so much different. The types of embedded system. The various types, we can classify the embedded system based upon two basic performance, two basic differences based on the performance and functional requirement and based on the function performance of the microcontroller. For example, if we consider based on the performance and functional requirement, we can classify it in terms of real-time, standalone, networked, and mobile systems. Based on the performance of the microcontroller, we can classify it as small scale, medium scale, and sophisticated. So next we'll see the elaborate classification of an M system. Starting with a standalone system. A standalone system which does not require any kind of system. The examples of a standalone systems are MP3 player, digital camera, video game consoles, microwave ovens, and temperature measuring systems. For example, if you consider the MP3 player, it has its own battery supply and its own controlling unit, and it does not require any other external parameters, such as it's not going to have the network player, such as the playing Geo Music inside the mobile phone, which needs a network to play all kind of music that is being available in the cloud. So the MP3 player is a standalone system. It's a real-time member system. So the real-time member system is defined as a system which gives a record output in a particular time. So these systems of member system follow the time deadlines for completion of a task. The real-time systems are classified into two types, such as soft real-time system and a hard real-time system. We are not going to see those different types. So such as a real-time system which has to give the output in the real-time environment. The network systems. So the resources will be located somewhere, and we need a processing of all the system that is being connected networked environment, so that to produce an output. For example, if you consider a home security system, you'll be having this different sensor that is connected, mounted on a different areas, and we need to run through that any kind of protocol, communication protocol to get operated. So we'll be seeing the mobile embedded system. The mobile embedded systems are used in the portable embedded devices like a cell phone, mobile, digital camera, MP3 players, personal digital assistants, etc. The basic limitations of these devices is the other resources and limitation of memory. The small scale embedded system. Next one is a small scale embedded system, and these type of embedded systems are designed with a 8-bit. This is a very different classification of an embedded system based on the types of processor. The small scale embedded system, which will have the 8-bit or a 16-bit microcontroller, is activated by the battery for a developing embedded software for a small scale embedded system. The main programming tools are editor, assembler, cross compilers, and integrated development environment. So, for example, automatic chocolate vending machine is an example of a small scale embedded system. The medium-scale embedded system is a lighter, bigger version which consists of a 16-bit or 32-bit microcontroller, the RISC or DSP processor. So the types of embedded system has both the hardware and software complexities. For developing a embedded software for a medium-scale embedded system, the main programming tools are C, C++, Java, Visual C++, Autos, debugger, source code, and code and engineering tools, simulators, and IDEs. So the complexity is very much higher when compared to the small-scale embedded system, and also the logical operation, the complexity is also getting higher. The next one will be the sophisticated embedded system. The sophisticated embedded systems, these embedded system has enormous hardware and software complexities that may need a application specific integrated processor and integrated processor and a PLA, that is a programmable logical array, a scalar or configurable processor. They are used for the cutting edge application that needs a hardware on software code design and components which have to assemble in the final system. So these are the So these are the various categories of an embedded system. So I'll giving you one task. So write the list of components and rules for the following embedded system. Consider refrigerator, washing machine, air conditioner, and ATM machine. So you have to write what are the various components available and what are the rules has to be fixed to operate for the operation of the effective operation of these embedded systems. So thank you all for listening, and this is the end of the first session. Next we'll be seeing the various categories of processor the next session. Thank you.